Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Here you can find other interesting subjects along with the engineering drawing. Do subscribe the channel and get alerts. Now, let's continue with the projections of plane surfaces, that is square. Here, let's take a square lamina ABCD of some sides length is given and resting on its corner in HP. Surface angle is given, and here if you observe, the surface angle is it's making 40 degrees with HP and 50 with VP. The sum of these angles is 90 degrees. So it's a typical problem here in this, and let us see how to get it. So this is the plane initially taken, and its surface angle 40 degrees is shown with HP. When you actually take this, suppose if I imagine a vertical plane here, a line, and this angle is 40, automatically this will be 50 degrees. So when you actually turn this plane by 90 degrees, this plane will be making a 50 degrees angle with the vertical plane. So that is possible with even other set of angles like 20, 70, 30, 60, like that. Okay, 10, 80, anyway. Now, let's see how to draw this. Coming to this, it has one corner in HP, the other corner in VP. Let us see how to get it. Let's draw the projections. Take the plane in the top view. Square is drawn in the top view because its surface is making angle with the HP. So, first of all, take the plane either parallel to HP or in HP. Whether it is taken parallel or in HP depends on the condition here. It is resting on one of its corners in HP. So something of this plane is in the HP. That's why take the plane in HP. That is one thing. And we want a corner in HP. That's why try to get a corner on either left side or right side here. So because of even number of corners, if you take a corner on left side, automatically in the right side also, you will get a corner. So here, let us see how to draw it. Next, show the dimensioning. Draw projectors from the top view. Let's draw the front view here. It is a line. It is the plane is in the horizontal plane. So it appears like a line in the front view. D is away from the observer. When your observer is looking in this side, the D is away from the observer, so kept in brackets. Now, let's keep the angle here, 40 degrees angle with the HP. So, drawn a line here, 40 degrees, same length is marked here, and this is at 40 degrees. So, mark the same points. Draw projectors from all these points here, and draw horizontal lines from these points. Mark the intersection points here, A, B, C, D. Join them by straight lines. You get the top view here. Now, let's reproduce the top view here such that the corner C is in VP. We want this corner C in the vertical plane. So, let's take a point here, right, and name it as C. Now let's reproduce this by taking this, by rotating this by 90 degrees. That means this entire plane should be rotated by 90. So this AC line, which is parallel now to VP, will become perpendicular. So from C, draw a line here at perpendicularly. This becomes A. So mark A here. With these 2 points as reference points, get all the other 2 points also. So here, from A, another one arc, from C, another arc, get B. Similarly, D here. Join them. So these are the diagonals of the square. Join these corner points, you get the top view here. So the same top view is reproduced here such that this entire plane is rotated by 90 degrees. Absolutely, there is no difference between this top view and this top view. Only the position has changed. Now let's draw the front view. Draw projectors from these points and horizontal lines from these points. Now join these, get the intersection points here, A, B, C, D in the front view. That's why A dash, B dash, C dash, like. Now, join them by straight lines here. This is the final front view and this is the final top view. Here, if you observe, the point A is in the horizontal plane. In the front view, if you see, point A is in the horizontal plane. And here, when you see this one in the top view, point C is in the vertical plane. Okay. Actually, this, even if you observe the diagonal AC, the diagonal AC here in the front view as well as in the top view is a straight line perpendicular to the reference line here. This angle, if you see 40 plus 50, 90, when it is 90 degrees, if you consider only the diagonal, this diagonal line is a straight line here. The A dash, C dash as well as AC, the top view, entire line appears is like a perpendicular line here to the reference line. That is possible only when this set of angles is 90. You take 10 plus 80, 30 plus 60 or 40 plus 50, whatever it is, this is possible. So here, this is a typical case of the square lamina. Okay, next. Let's take another one. Square lamina ABCD resting on A, that's a corner, and it's a surface angle with HP. The diagonal AC passing through the point on which it rests on HP is making an angle 45 degrees. This 45 degrees angle is the true inclination. Let us see how to get it. And also let us see the difference between the earlier ones and this one now. So this is the plane taken in the first position, surface angle with the HP, right? And this is the top view. Now coming to the final position, here we have to find the apparent angle because this 45 degrees angle given here is true inclination. How do we know that? Let us discuss clearly. So these are the final projections of the plane surface. Now let's draw the projections, right? So here, let's take the square in the top view such that the diagonal comes on either left side or right side because we want the corner in HP, A in HP. Now, let's draw the front view here, draw projections, projectors here, draw the front view, and this is the front view. Draw here, show the surface inclination with the HP, draw a line at 40 degrees angle. The same front view is reproduced here. Draw the top view, draw projectors and horizontal lines here. Mark the intersection points, join them by straight lines. Now, if you observe, the AC diagonal is making an angle with the HP, this line. Forget about everything. Consider only the line, AC. AC is making an angle 40 degrees with the HP. Suppose if I take this AC line, right, here at some angle here, then that will be an apparent angle. But here it is given as the AC, the passing through the point on which it rests on HP. It is the point on which it is resting is A. So the diagonal passing through this point is AC. AC is making means it's actual inclination, true inclination. So this 45 degrees angle is a true inclination. And if you take this line AC at 45 degrees angle, that will become apparent angle only. But that will not be the true inclination. So what to do? We have to find the true inclination, apparent angle here. How? Let's suppose when do you see the true inclination? When the line is parallel to the horizontal plane. So let's take the line in the parallel to the horizontal plane like this. So draw a line here at 45 degrees angle first. Now let's take the actual diameter. When the line is parallel to HP, we will be able to see its true inclination and also true length. True length means this is AC. This is the true length of this line AC. So let's take this length, not this length, not this inclination line length. So AC true length is this one. This length is marked here, and I call it as C1 because it is some initial position only, not the final projection. Now, when this is making 45 degrees angle with VP, the point C, A is fixed. Point C will be at this distance in front of VP. So draw locus of C in the top view. The point C must be in this locus. Now, you can refer to get this apparent angle, you can refer the projections of lines. Previous videos, we have clearly discussed this point where there. Now, coming to this, now let's take this actual length which is appearing in the top view, that is this AC, from A as center, this AC as radius, draw an arc here intersecting this locus. This point will be called C here. Now, this is AC. Right? This AC is this one. This angle is actually the apparent angle, that is beta. So once you find this AC or this apparent angle, now we are ready to reproduce this top view here. We can reproduce this top view by taking this AC reference points. Now, get the other points here, B, D, join them by straight lines. We have just reproduced the same figure here in the top view. Now, let's draw the front view. Draw projectors from these points and draw horizontal lines from these points here. Join these points by get the intersection points here. You get 4 points. Join them by straight lines A, B, C, D. You get the front view. So here we did 2 things. One is we have to get the apparent angle here. And on this apparent angle, you have to reproduce the same top view. That care should be taken. And you have to, first of all, you have to identify whether this given angle is a true inclination or apparent angle. Okay. So these are the final projections of the plane surface when these 2 angles are true inclinations. Okay. So hope you had understood this topic very well. And if you have any queries or any doubts, please do comment, like, share, and subscribe. Thank you.